Okay, so I'm too lazy to write an essay on this, so I'm going to be saying it out loud to help me study because I don't want to type it because that just makes it sound miserable. So, the prompt is evolution is one of the unifying concepts of modern biology. Explain the mechanisms that lead to evolutionary change. So, the mechanisms that lead to evolutionary change are comparative anatomy, which includes homologous structures, which are structures with the same structure, but they don't have to have the same function. They could be different or same. And this mechanism supports divergent evolution, which is where organisms come from like the same common ancestor that happened recently. Comparatively, analogous structures also fall under comparative anatomy, and analogous structures are the same function but different structure. So, like for example, birds and flies use wings to fly, but birds' wings have bones and flies don't. And this mechanism supports convergent evolution, which is where they don't evolve from a similar common ancestor. So if it's divergent evolution, where my fingers meet is a common ancestor, organism, and for convergent, it's just organisms being made. So another thing that supports divergent evolution and homologous structures is vestigial organs, which are like something on your body that used to be like useful but no longer are. An example of that is your wisdom teeth. So humans used to need their wisdom teeth to um they used to need wisdom teeth to like chew like meat, like because like when we were like cavemen, like you had to uh like chew like raw meat because that's just how it was. And now we don't need to do that. So if you have a lot of wisdom teeth, you're less evolved. But if you don't, then you're not as evolved. And this also adaptive radiation supports divergent evolution because like if you're in a common ancestor up here, then and you go down, like the you like adapt to like your like I don't know how to explain it. You like adapt to your like environment, but like over time, not in one, not just this isn't just one person. It like keeps going. Okay, so the next one is biogeography. So like if your land like habitat like changes, then the organisms over time are going to change. And this is cuz like whatever like is going on in your habitat, like you gotta like be able to live in it. Like for example, um like the finches at the Galapagos Islands, uh their beaks, like if you like wanted to eat a certain fish, you like have to like make sure that it's like the right type of beak for that certain thing. And the beaks with the better beaks, I mean, the birds with the better beaks are going to live and reproduce and pass on that gene. But the birds with the bad beaks are going to die off and not be able to reproduce, and therefore that trait will say bye bye. Next, oh, I already said adaptive radiation, but I'll explain it in better detail. So that means various species develop from a common ancestor in a new environment. So if the common ancestor says peace y'all and moves to Alaska, then they're gonna split off from that common ancestor to create homologous structures, because it's like coming off and they're gonna be like that. And this can happen without barriers as long as there's like microenvironments for organisms to adapt. Next is artificial selection, which is by humans. So like for example, like breeding dogs, like you like take two different breeds, like if you take a beagle and a chihuahua and you breed them or make them mate, then a cheagle is gonna come out. Like Pepper Angler, that's a cheagle. And it's a basis for natural selection, but the humans dictate it. So if they want to make like a more better dog breed, then they're gonna mate two together. Next is comparative embryology, which shows that the more similar that your embryos are to another organism, the more like evolutionarily similar it is. So for example, humans and pigs are really similar. Like similar looking when they're like in the embryonic and fetal stages of pregnancy. So, and even like in the first stages of organ transplant, humans would take pigs' organs and put it in human bodies. That's insane. And then the strongest evidence for evolution is comparative biochemistry. And this is because all living things use the same basic biological molecules for similar functions. I'll break that down. Nucleic acids, everybody got nucleic acids because every living thing has genetic information from DNA and RNA, which are nucleic acids. And everybody got enzymes, so that's proteins. ATP, which everyone got, carbs and fats, they store energy. So everybody got that. And lipids, which is what everybody has, are used to build membranes, which is like in your cells, in the organelles, all that stuff. The next evidence for this evidence is metabolic systems are similar among species. For example, photosynthesis, respiration, fermentation, everybody had got to go through that to make energy or to use energy to make oxygen. And also genetic code, gene expression, making proteins, all that stuff happens to everyone. Lastly, in this evidence, basic cell structure is almost universal. So almost everybody, like organisms wise, like, well, duh. Like heterotrophs all got that same cell looking thing, and then autotrophs all got that same cell. And this is the most important part of this evidence. How similar the monomers of biochemical compounds of life are 100% sports how closely related you are to another organism and how similar your common ancestor is. So if me and a monkey have similar monomers, so if we got similar monosaccharides, if we got similar amino acids, if we got similar blah blah blah, we're closer related. For example, cytochrome C. Listen, y'all. Cytochrome C is an electron acceptor in the electron transport chain. That is used to prove how genetically similar you are to someone. And this means, especially for proteins, if you got, like, when there's a mutation, it doesn't always mean that your amino acid is gonna be different. Like, for example, like, I don't know what the, like, exact, like, codon sequence is for cytochrome C, but let's say it's, I don't know, ATC, but let's say it's AUC, but if it's AAC, that could also code to cytochrome C, but it also couldn't. But if me and a monkey both have AUC as our codon sequence, then we're more similar. But if me and a bear, if I have AUC and they have AAC, that makes us less similar, but it'll still make it similar because AAC still translates to cytochrome C. Also, the fossil record. The fossil record, it's like on the layer of ground. If this is the ground and this is the fossils, this is the most recent fossils. If the fossils is down here, then it's like not the right like this fossil is old as hell. Like this fossil is probably a million years old. Like for example, the fish, like prehistoric fish would be down here. But like dinosaurs would probably be around down here. But up here would be like dead like squirrels, like roadkill. And yeah. And the lastly, antibiotic resistance. So, antibiotic resistance happens by random mutations in bacteria. So if we got bacteria A, bacteria A, bacteria A, bacteria A, bacteria B, 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 C, 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 when the antibiotic, when you're sick, is given to treat the bacteria, some of the bacteria, for example, maybe A and B will randomly mutate, so it would be resistant to the medicine. So start over. So what if just A is resistant to the bacteria? That means, resistant to the medicine. So that means the antibiotics are going to kill B and C because they're not resistant, and A will last because it's resistant. And that means that A will populate and reproduce, so that set of bacteria will continue to spread throughout your body. So that's a little scary because that means not all the bacteria have been killed and you're finna still be sick. So get well soon. And you gotta find a new antibiotic that will kill bacteria A because she's thriving through your system as we speak. And human environments, like in like your stomach or in like your lungs, like that environment is where the bacteria thrives. It's the best for that. So that means you really gotta find a good antibiotic that will kill it all. Thank you. I hope you enjoyed my essay that I said.